On January 5th, China launched a massive airship 2,000 meters into the sky, higher than 5 Empire State Buildings stacked together, and plugged it directly into the power grid. This isn't a concept. It completed a test flight in early January 2026 and generated 385 kilowatt-hours of electricity that fed into the local system. Now here's what makes this moment bigger than one test. While China is building power plants in the clouds, Europe is going underground, into abandoned coal mines 500 meters deep, using 2,000-ton weights to store energy. For 100 years, power plants sat on the ground. So is this the next generation of power, or just another experiment? If it is, it's because these systems solve a problem that ground-based power never could. Wind at ground level is weak, turbulent, and constantly blocked by buildings and trees. But if you go high enough, everything changes. Think of the atmosphere like an ocean, but flipped. At ground level, you're dealing with choppy surface waves, chaotic and unpredictable. But if you rise up between 500 and 2,000 meters, you find massive rivers of air flowing in one direction with incredible power. The winds up there aren't just a little stronger. They are consistently 2 to 3 times more powerful than anything a traditional windmill can reach. And wind power follows a cubic law. That means if you double the wind speed, you don't just double the power, you get 8 times more energy. So when these airborne systems tap into winds that are 2 to 3 times faster, they're getting 27 times more energy from the same size turbine, which is a massive difference. Traditional turbines stuck on the ground only generate power about 20% to 40% of the time because the wind isn't always blowing down here. But up at 2,000 meters, the winds are so steady that these systems can potentially run over 50% of the time. That's getting close to the reliability of a coal plant, except it is completely clean. So, how does the S2000 actually work? The S2000, short for SAWS, or Stratosphere Airborne Wind Energy System, is the result of a rapid development push by Beijing-based Linyi Yunshan Energy Technology, working with Tsinghua University and the Chinese Academy of Sciences. Just 15 months ago, in October 2024, the team tested their first prototype, the S500, which generated only 50 kilowatts. By September 2025, they'd scaled up to the S1500, a 1.2 megawatt system tested in the remote deserts of Xinjiang. But that version couldn't handle the turbulent winds near cities. The S2000 represents a complete redesign. Engineers upgraded the weather resistance system and reinforced the structural envelope to survive the chaotic airflow near urban areas, something previous versions couldn't do. The January test in Yibin marked the first time any high-altitude wind system successfully connected to a power grid. Think of it as a massive floating ring, 60 meters wide, filled with 20,000 cubic meters of helium to keep it airborne. But it's not just a balloon with a fan strapped to it. Engineers designed a specific duct shape that funnels air through the center opening at high speed. This blasts air directly into an array of 12 wind turbines. The electricity travels down a simple tether cable directly into the grid with just a cable and a small ground station. A single unit pumps out 3 megawatts, that's the system's rated capacity at full operation. During the January test, the S2000's maiden grid-connected flight, it ran for several hours, generating 385 kilowatt-hours that fed into the local grid at Yibin, Sichuan province. Once the system is fully operational and running at peak capacity for 1 hour, it generates enough electricity to charge 30 high-end electric vehicles. And the company behind it isn't stopping at one. They're building a production facility expected to reach full capacity by the end of 2026. But China isn't the only one realizing this. While China is betting on giant airships, other countries are joining the race with designs that look completely different. The competition is moving fast and taking completely different approaches. Take Germany, for example. Sky Sails Power is a German company that took a completely different approach from China's airship strategy. In July 2025, Sky Sails completed Asia's first airborne wind deployment in Lukang, Taiwan, flying their newest system called the Kyo. Imagine a high-performance kite the size of 2 tennis courts flying in a figure-8 pattern hundreds of meters in the air. As it moves, it pulls on a tether cable connected to a ground-based winch and generator. The Kyo system can hit 450 kilowatts and produce enough energy to power 600 households. And because it's accessing those high-altitude winds, it can run for up to 5,000 full load hours annually. Most solar panels are lucky to hit 1,500 hours. SkySails didn't start here. The company spent over a decade developing kite-based ship propulsion systems before pivoting to energy generation in the late 2010s. The challenge was altitude control. Early prototypes couldn't maintain stable figure-8 patterns in shifting winds, causing tether failures. It took years of testing different kite materials and automated control systems before the July 2025 Taiwan deployment proved the concept could work reliably. Then there's Kite Power in the Netherlands. They've developed a Falcon system that fits entirely inside a single 20-foot shipping container. The whole thing can be transported anywhere in the world and deployed in less than 24 hours. They're targeting disaster zones, off-grid mining operations, and military bases. The Falcon generates 100 kilowatts and uses 90% less material than a traditional wind turbine of the same capacity. The global airborne wind energy market is projected to reach $1.8 billion by 2030, with dozens of startups competing for early deployments. But so far, no one has proven the economics work at scale. The real test isn't whether these systems can generate power, it's whether they can do it cheaper and more reliably than conventional wind farms. And that brings up the one problem every single one of these companies is facing. What happens when the wind stops? Or when nobody's using electricity but the wind is howling at 2,000 meters? You need to store that energy. And lithium-ion batteries, they're not the answer. They degrade after 10 to 15 years, they're expensive, and the supply chain for lithium and cobalt is a geopolitical nightmare. So engineers thought, what if we could just lift something really heavy when we have extra energy and lower it when we need power back? Welcome to gravity energy storage. When you have extra energy, say from a floating wind turbine at midnight, you use that electricity to lift a heavy weight. When you need that power back, you just let the weight fall. Imagine a massive building made of steel and concrete. Inside, automated cranes lift giant blocks to the top. It's basically a giant mechanical battery. As it drops, it spins a motor and pushes electricity back into the grid. To see this in action, look at Energy Vault. It's a massive 25 megawatt, 100 megawatt hour system in Rudong, China, sitting right next to a wind farm. The system became fully operational in 2024 after years of development. The round-trip efficiency is over 80%, and unlike a battery that dies after 10 years, these concrete blocks will last for 35 to 50 years. But getting there wasn't simple. Energy Vault's first prototype in Switzerland in 2020 struggled with precision. Stacking 35-ton blocks with millimeter accuracy while a crane swayed in the wind proved nearly impossible. Engineers had to develop custom stabilization systems and AI-controlled stacking algorithms. The breakthrough came when they switched to composite blocks that could handle slight misalignment without compromising structural integrity. The Rudong facility represents the first commercial-scale gravity storage system that actually works. But the coolest version of this technology is actually happening underground, and it could give a second life to thousands of dead mining towns. There are abandoned mines scattered across former coal regions: Pennsylvania, Wales, Poland, West Virginia. These mines already have the infrastructure: power lines, access roads, and shafts that drop hundreds of meters into the earth. The same towns that lost their economies when coal died could become the backbone of renewable energy storage. We're talking about taking a mining town that's been economically dead for 20 years and turning it into critical grid infrastructure. A Scottish company called Gravitricity is proving this concept in Finland. In 2024, Gravitricity signed an agreement to develop a prototype at the Pyhäsalmi mine, one of the deepest mines in Europe, reaching 1,445 meters down. They're using a shaft that goes 530 meters deep to raise and lower weights that weigh 2,000 tons. To put that in perspective, that's the weight of 15 blue whales hanging on a cable. The system is designed to deliver 2 megawatts of power and go from zero to full output in less than 1 second. That makes it perfect for keeping the grid stable when everyone turns on their AC at the same time. And because it's mechanical, there's no chemical degradation, no fire risk, and no toxic waste. The market sees this coming too. Global gravity storage was valued at $1 billion in 2025. By 2040, it's projected to hit $45.9 billion. That's massive growth. But here's the one thing that makes gravity special. Think about your phone battery. Even if you don't use it, it slowly loses charge, right? Gravity doesn't do that. If you lift a weight and leave it there for 100 years, the energy stays there. As long as gravity exists, that energy is waiting for you. No leaks, no degradation, no waste. So where does this all go? The next few years will determine whether this is a breakthrough or just another expensive experiment. By late 2026, SOARS will shift from testing to small batch production. Kite Power is already shipping containerized units to off-grid sites, and Energy Vault has projects under construction on 3 continents: China, Texas, and Australia. But the real story isn't the gadgets. It's what grid operators are demanding. In the US and Europe, utilities are starting to require grid-forming power, systems that provide the stability batteries can't match. That's pushing gravity storage from a curiosity to a requirement. Here's the milestone that changes everything. Gravitricity's prototype in Finland. If that mineshaft successfully stores and dispatches power to the grid, it opens the door to thousands of other abandoned mines worldwide. We're talking about former mining regions that have been economically dead for decades suddenly becoming the backbone of renewable energy infrastructure. But here's what makes this moment different from every other renewable energy promise you've heard. For decades, the grid has been stuck in 2 dimensions: flat solar panels and ground-based wind turbines fighting for space on the surface. What China proved on January 5th wasn't just that you can fly a power plant, it's that you can build a grid in 3 dimensions, harvesting energy from 2,000 meters up in the sky, storing it 1,000 meters down in the earth, and leaving the surface for people to actually live on. That's not just more efficient. It's a completely different way of thinking about infrastructure. But here's what I actually want to know. Which one do you think we'll see at scale first? Airborne wind systems floating over cities, or old mines turned into gravity batteries? Let me know your prediction in the comments. And if you want to see more Megabuild stories, make sure to subscribe. Thanks for watching.